The least amount of ignition timing advance that delivers full power is perfect. Well, as far as you're going to get with the type of tuning tools that most of us have available to us. So if you're going to set up a distributor, that's quite a skill when you think about it. There's all those different functions that the distributor encompasses, and we've got to get it all happening at the right time to deliver the proper amount of ignition timing advance as conditions change and so forth. Sun Analyzer Corporation used to sell distributor machines. Used to own one, and it was like a dyno for a distributor, and you could map out the mechanical advance curve. You could go in with a vacuum pump and you could check the vacuum advance curve and plot it all out. That way you had, this is start, this is end, this is sweep, this is where your timing is all along the way. It was great. The carburetor delivers the fuel, whereas the distributor controls the spark. The carburetor delivers the fuel, mixes it with the air, and in its simplest form, it's just like a metering device. You're going to have an idle set screw. So as you open the throttle, the throttle plates will open. Well, you can adjust that. There's a little screw on the throttle shaft. So that's one of the adjustments that you would make to a carburetor. When the throttle plates are fairly closed, your air-fuel charge is coming through a dedicated idle circuit that kind of goes around because your boosters aren't getting any vacuum at all. So all of your idle air-fuel mixing is done through the idle circuit, which is adjustable. Once you crack the throttle open, that idle circuit pretty much shuts down. It no longer does anything, and your main circuit kicks in. So you'll have a booster where the fuel comes into the air charge. It's in a venturi so that it creates a little vacuum, and then the fuel comes through a fixed orifice called a jet. And the jet, if you go bigger, that means for any given venturi vacuum, you get more fuel. A smaller jet, for the same vacuum, less fuel. When you step on the throttle, you're cruising at 14.7 to 1. You pounce the throttle. Now you need to enrich it, like a 12 to 1. You'll have, like Holley's, use a power valve. Now the power valve has two ratings on them. One is just how much fuel is it going to dump. And the second rating is at what vacuum level. Again, getting back to the stock cam, 18 inches of vacuum, where you need the power valve to kick in might be 5 inches of vacuum. If you've got a healthy cam in there, you're only getting 10, 12 inches of vacuum at idle. So it'll be kicking in way too soon. So now you get a power valve that's rated at like 2.5 inches of vacuum. With Carters and Rochesters, this is all done through metering rods. So you have your jet on the floor, and then you have a plunger that comes down. The plunger is smaller than the jet, and the plunger is called a metering rod, and it's stepped. So the bottom part of the metering rod is usually pretty skinny, and then you get to a step point where it gets fatter. Attached to that metering rod is going to be a piston or a plunger that's spring-loaded open. So when you have high engine vacuum, late throttle, the vacuum pulls that metering rod down so that the fat portion is plugging that jet partially. So you get, a 14 to 1 or 15 to 1 air-fuel ratio. When you step on the throttle, vacuum goes down, the spring overcomes, and it pulls that metering rod up. So now the skinny part of the metering rod is partially plugging the jet, allowing more fuel into the main circuit. There's your enrichment. Popular carburetors will have tuning kits. So it'll have an assortment of jets, if applicable, metering rods, springs, where you can go in, you can custom tune your air-fuel ratio curve by just swapping out mechanical parts. The choke kicks in when cold. Part of the whole combustion process is vaporizing the fuel. Well, with a warm engine, the heat of the engine helps to vaporize that fuel. When the engine's cold, you don't have that heat. So it takes more total fuel to give enough fuel vapors just to get the engine to run. As the engine warms up, the choke applies less and less influence, and it kind of leans back out to your main setting. The choke is a bimetal spring, and when it's cold, it pulls real hard to close that choke plate. And then as it warms up, it pulls less and less until finally it's not influencing at all. These chokes are always adjustable. I mean, every one that I've seen anyways, where just how much tension does that bimetal spring apply. The heating process, sometimes it's just engine heat. Usually, they're electric assist. And so that helps to alleviate the influence a little earlier. And then finally you have a choke pull-off. It's a diaphragm with a little linkage on it. And when you get the engine running, it starts pulling back on that choke a little bit so that you're enriching less. So when all of this stuff comes together, you get a fairly reasonable fuel economy and performance out of an old-fashioned distributor and carburetor. Now, of course, a wideband O2 would help with setting up the carburetor. Another trick is just reading the spark plugs. The coloration on the spark plugs can tell you if you're running rich, running lean, and so forth. When we get into the electronic fuel injection, computer-controlled ignition, and so forth, you're not going to just twist a distributor or swap out jets. You have to deal with it electronically. And at the bottom of the scale is that OBD2 chip tuner thing that I mentioned. Just plug it in, hope for the best. It's going to have generic algorithms, which may or may not be ideal for whatever hardware changes you made. I've not used them. I say this again, I only mention them. They claim to be 100% emissions legal, so it won't screw you up when you go in to get your emissions test done for your registration. And the reviews I saw, man, I love the performance, but I'm still waiting on those fuel economy gains I was promised. Then we get into the influencers, your map adjust, your performance module, IXRs. First of all, map adjust, as we mentioned in the electronic enhancer section, by altering the VREF, the 5-volt signal. You drop it down, then your signal drops down proportionately. And that'll affect your barometric pressure reading as well as your load reading on map-equipped vehicles. So as you have less load, it's going to ask for less fuel. Of course, the feedback system will ultimately dictate your air-fuel ratio at cruise and idle. And then it'll also ask for more ignition timing advance. Lighter load, less fuel, more timing advance. If you take the VREF higher, then it's going to ask for more fuel, but retard the timing. And if you need timing retard, at least at cruise conditions, the feedback system can kind of help you out there on the air-fuel ratio. Performance modules that alter the air intake timing. Now, on the newer vehicles, they're actually going to work when you first wire them in. They will work, maybe even after a cold start, they'll still influence. They'll quickly get calibrated out. But if you want to test and see if additional timing advance, which is what they're all designed to do, if advance is going to help, you can put a resistor in there or a performance module, test, see if you get the benefits. If you do, then you can upgrade to something a little bit more expensive, more sophisticated later, and go and fine tune it. So when you put a resistor in parallel, now the total resistance goes down. The computer sees a hotter mixture, which will retard timing. If you put it in series, the computer sees more resistance, which is colder air, and it will advance the timing. Again, you can use the resistor just to see if it's worth your while to take more drastic measures. And then the IXRs, whereas the performance module air temp circuit only really affects the ignition timing, the IXRs go in parallel with your injector, and they really only affect the computer's ability to capitalize on lean commands from the oxygen sensor. So 14.7 to 1, 14.7 to 1. IXRs don't change that, but you'll see your fuel trims happier with that. Moving up from influencers, of course, the Unichip I mentioned. It wires in with your injectors, your ignition coil, where you literally have to cut the wires. You have one ignition wire, you cut it, and then the Uni chip has one wire that goes to the ECU and a second wire that goes to the actual injector or coil. So they do have to be hardwired in, and then in addition to that, you have to like splice in, where you're not really cutting, you're just splicing in too. Temp sensors, crank sensor, cam sensor, and so forth. And then this gives you the ability, you can XY table, you can go in, you can do your tuning, comp tables. The factory ECU can delete some of what you do, especially on the fuel side. Works very well on ignition because very few vehicles have some kind of feedback for the ignition outside of like a NOx sensor. But your fuel ratio, you got your oxygen sensor, and if you're going in there and saying less fuel with the Uni chip, then the fuel trim say more fuel, and you wind up, no gain really, and then your fuel trims are out of whack. And you might set a code, but you don't really get the gains. But the Uni chip, you're not going to get a re-flash from the factory overwriting it, which we'll get to here. Just remember re-flash. Then we get into HB Tuner, Diablo, Data. That's where you can go in and overwrite the factory settings, the factory tables. These offer a lot of support. You got to buy the tool or the software for your laptop, whichever is applicable. Then you have to buy a license from the OEM, and I think like $75 is the going rate last time I checked. And then with those in hand, you can tune that VIN, that vehicle with that VIN. It won't work on any other vehicle on the planet, just that one. Once you've got the purchase made, now you would go in and you would just save. All right, you're not going to change anything initially. You're going to go in, you're going to save whatever the factory put in there. You're going to label it, stock tune, give it a date, and you're going to keep that. You may need to reference that later. And if you screw up in your tuning, and you say, oh my gosh, what did I do? You can go back in and revert back to stock and take two, start all over again.